안녕하세요.
안녕하세요. 근데 이거 오늘 미팅 한다 그랬나?
저번 주에 안 한다는 말이 없었어요. 주소가 이거 맞죠? 두 개가 있네.
어, 딴방일 수도 있는데. 근데 줌 맞잖아요. 드루. Hi, 드루. Good morning. Hi, Charlie. Good morning.
Oh, I think you're on mute.
Hey, Drew. Morning.
Hey, how are you doing, Evan?
Good. How are you?
Oh, pretty good. Staying busy. I got up early this morning to get here, so I'm, I'm
I get a
dragging
little nervous when you say early. I think that means a very different thing to you than it does to me.
4:30. I
Yeah.
mean, there's
Say
some
I got up
pain.
fairly early today too, Drew, but like 6:30. You still got a couple hours on me.
Yeah, well, when I work at home, but um, the problem is been having these big storms in California, and so there's another one coming. I think tomorrow and Thursday, and tomorrow should be fine. So I'll fly to work tomorrow, but I want to try to get to work 3 days a week, so I get an office here,
Yeah, yeah.
and uh, and so I'm like, oh, I guess I'll get up and fly in. But um, yeah, but then Thursday I can stay home and not worry about it.
Nice. Yeah. We'll work around the storms.
Last Thursday I flew through the storm, and that's one of the reasons I got up this morning.
Yeah. Recent experience.
Yeah, I was coming into land, and the plane was backfiring on the approach. I was in the clouds. It was night, and I was getting shaken. And I'm like, "What's going on?" I look over, and I'm like, "Oh yeah, I'm at 2% power," and that's kind of normal for it to do that at very, very low power. But I was going really fast, and so it turns out, I'm not that high. I'm like 2,000 feet, 1,500 feet, going 100, like 200 miles an hour, and with 2% power. And I was caught in an updraft. And so I was
Oh,
diving through the updraft, trying to get down to the runway, and it was no big deal. If I decided it was unsafe, I could have just aborted the landing and then go land somewhere else where it wasn't as bad, because there were plenty of other clear airports other than my home airport. But I did it. I pulled up a little, got the flaps down, and got down on the runway. And but I'm just like, "Oh, I don't think I want to do that next week."
yeah. Good to avoid it if you can.
There was 60-mile-an-hour winds at altitude, so
Wow.
that's what I think I was caught in. I think I was caught in wind shear,
Yeah.
where a layer was ripping over another layer in the air and peeling it up and causing an updraft. Anyway,
Not problems I have on my commute, Drew.
different pain for different folks, but
Yep.
yeah. Well, why don't we dig in? I think we're close to having the 1.0, but I'll share. I think, I didn't hear that Yogesh wouldn't be here, but
Yeah, Yogesh sent an email to you and me, Drew, like, I don't know, 30 minutes ago saying he wouldn't make it.
oh, okay, I missed that.
Yeah.
I was traveling. Okay. So I'm just going to scroll through this. I think, I don't know what that comment was. That's a floating comment. Okay. Well, I'm going to go, I guess, let's just look through the document. Well, I think our task was um, to review it. I'm looking at this.
Yeah, the one you assigned me last time, Drew, is
Oh
at the
yeah,
top of the boot time data logging chart. That looks like about where you were last time.
yeah. Because I was thinking that this is all pretty much closed off. Okay.
Yeah. Yeah, so that very top one, the pointer for system date of birth, you asked if it was needed. My answer is kind of. Depends on what we want to do. The reason that's in there is we get asked for time to fail metrics a lot,
Yeah.
and without some like birth or first install time, we don't have that. But like I see the side here where that is that kind of moves away from the analyzer being stateless and just being fed in whatever error info you have.
Well, it's fine. I don't think it hurts anything. The only thing that's a little tricky is what is the birth of date or date of
Hmm.
birth? Is it like L10 assembly? Is it, when it was slid into the rack, when it was first powered on? So what does this mean? And then what time zone is the timestamp in? Like,
Yeah. Yeah, first power on's kind of what we've normally gone with, but
okay.
that's one of those that, I mean, yeah, it does matter a little bit, but it's all kind of close enough for a time to fail type calculation.
Okay.
So I mean,
So
maybe we put power on there. I don't know if we want to make that kind of an optional, like if time to fail data is ever desired, because it's not strictly required for the actual error analysis.
let's see. Yeah, let's work on it for a second. I mean, I wasn't pushing back. I was just trying to figure out how important it was. And I guess the other question is, we don't have any system people here. Well, we have Charlie, but I'm thinking Intel or AMD. Is this going to be hard? Oh, is Mita here? Sorry, I have a limited list of who I see on the call. Oh yeah. Oh, and Anil's here. Okay. So uh, I'm fine with calling this. Uh, we can put some intent in here, and we should take the question mark off. And then why does it say GUID?
That I don't know.
Pointer for system date of birth.
Yeah, regarding the date of birth is a little bit ambiguous. So there is two kinds, as Evan said. The first one is the assembly time of a theme, and the other one is the production in time. So that means that normally if the device failure is due to the degradation of the active devices, then the rather than the assembly time, the device production in time, the operation time is much more important in terms of the degradation estimation.
Okay. Well, and I think also, can't you infer the assembly time from the serial number to some?
Yeah.
Yep.
Normally the serial number has the assembly time. We
Yeah.
can track the information, but the production in time is up to the log generator.
So maybe we Would anyone object to just getting rid of the word GUID and say pointer for system date of birth? And that would be along the lines of what you're saying, Roy, you know, kind of the
Yes,
operation time.
yes.
Yep.
But I think the question here is like, how is it different from the primordial boot timestamp? Which is
Is
like,
there a primordial? Oh,
there's
there
a-
is.
yeah,
Oh, then in my mind, it's not, Mita.
okay, yeah,
I think that's all we need. I think that, Roy, that's what you were saying too, right? The first boot timestamp, the
If
primordial
you
boot
look,
timestamp.
yeah, and my mistake. Yeah, it's right
Yeah.
here.
That's actually, and I was reading Owen from Micron here, made that comment on the right, basically asking that same question, like, how is this different than the one below?
Yeah.
All right, yeah,
I think we don't need that. I think we can just delete that row then, because we
yeah,
have what
agreed.
Roy was talking about, the operation time. So,
Yep.
okay, any objections? Thank you, Mita. Let's see, delete row. Okay, problem solved. Okay, I can talk to Carlos about this, but log format, I'm not sure what this column is, you know. I don't know how we use this. I think what we've got to do is we want like Intel and AMD to log the data, and then they need to translate it into a format that you all can use that's consistent. And so, but I don't know how we want to handle that here.
I think what I'd been working toward, Drew, and I still need to work with Owen and get some of this in here, is to get some that schema that he kind of built off what Carlos had
Yeah,
for kind of a JSON type schema. Get some just a couple examples into the doc of like what that looks like, and then have kind of an appendix reference to that overall schema.
okay. Do we
So
need that? I think that's a great idea. Do we need that for the 1.0 version of the doc?
strictly speaking, probably not. I've been kind of concerned in general about formatting alignment. It doesn't necessarily have to be in 1.0, but the the formatting alignment will help the memory vendors a lot.
Yeah, I can see
Because a
that.
lot of what we're trying to avoid is building kind of individual parsers for various formatting schemas,
Okay.
from Micron's perspective anyway.
Do you think that that's something that you could put in quickly?
I think we can at least get a link to the draft of the schema. I mean, we've gone over that in here. I think it still
Yeah.
needs some work, but I think everybody was at least on board with kind of the general format.
Okay.
And we have kind of everything captured here that we wanted to log. So I think that can work for kind of an initial release version.
Okay. So
Let me catch up with Owen again today. Owen was having issues getting stuff into the doc too.
oh, okay.
And it's always hard for me to tell, Drew, if that's a Google Docs permissions problem or a Micron permissions problem.
Okay.
But I think it was working for me, so I can work with them.
Okay. Well, and I guess then, you know, the question will be, what do we do with the log format column?
Yeah.
I don't know.
I don't think we
It's,
need this column, right?
well, that's kind of what I'm thinking, is that what we could do is if we have, you know, Owen and Evan's intermediate representation, like one of the problems is that, you know, AMD and Intel log memory areas very, very differently, and that's fine. They'll just have different CPERs, but then when they send it to the memory vendor analyzer, they'll be able to translate it to an intermediate form that's consistent. So I don't know that we need it. Let's ponder that. I think I'm inclined to delete it too, but why don't we walk through this a little further and see?
Because that CPER details link, Drew, that just goes to like the CPER definition doc, doesn't it?
It sure does, yeah.
Which is maybe a
So-
helpful link to have in here somewhere, but we don't need a column for it.
Right,
Yeah.
right.
Just in the like notes somewhere.
Yeah.
Well, there should be a references doc. I mean, I'm sorry, sorry for the fast scrolling. Yeah, we have references. And so the spec is referenced there.
Isn't the CPERS detail just what's in that table there? So the CPERS detail would translate all that information from an AMD or an Intel into the first column in the table.
It would, yeah, but I guess the point is that like the memory vendors probably want a consistent representation no matter who's doing the logging. And so that's why we'll have the JSON that specifies that kind of intermediate representation.
Okay.
And like with, you know, some people log bit flips, some people log syndrome information. You got to do a little bit of math to get the bits that were flipped. They're differences between the logging, and that's okay. That's as long as we get the data and we can give it to the memory vendors to analyze, then I think we're okay. We're not forcing all the memory controllers to be designed exactly the same way.
But Drew, I mean, in the current specification spec, right, the UFI spec, there is a format already defined for memory errors. Are you referring to memory runtime error or boot time? Because boot time error is not defined. If you're
I'm
referring to-
ignoring the error logs defined in the spec. I
Why?
don't care. I don't because you know, this is the conversation we've had many times. I don't really care what the CPER looks like. What I care is that I can decode it and analyze it and get the analysis results. So the way to think of the CPERs in the UEFI spec is they're lowest common denominators, and they don't always fit. So I'm not forcing anyone to use those. I'm saying you need to decode it, and you need to have an intermediate format that the memory vendors can analyze.
I thought in the CPO there is a OEM segment where you can pretty much add whatever.
Or you can just have an OEM, a completely OEM CPER, and we don't care. It doesn't matter. I mean, I think the other problem is that there may be things grouped to the memory controller that make that not fit. So I don't think we want to be that prescriptive. I think we want to like make sure we gather that's the problem. In fact, that is the precise problem the UEFI spec made, is that it tried to specify the data in a way that everyone had to do things a certain way. And what we're saying is, we want the data. You can grab it however you want. And then when we decode it into something common.
I think this is conflicting, Drew.
I don't really care if it conflicts with the UEFI spec. We just
No,
ignore it.
not from it. Our own statement. If you go back to the way we are defining the data collection, right?
Oh, it truly is not. So you can grab the data and we've said this a million times, Neil, because the formats are different. The Intel and AMD grab things differently, and we're not telling them they have to change that.
Maybe let me make sure I understand you. Are you saying that each vendor can define their GUIDs and then format,
Yes.
which still follows the CPER semantics, like header
There's
and
still
all?
a CPER error record, yeah, but what's in it could be completely different between vendors.
Okay, if you're calling that, then I'm okay with that because that's how the CPER is defined. I mean,
Yeah,
so
that's what I'm saying.
so you're saying that we will still follow CPER semantics the way UFI spec has fine, but then the actual event log, okay, the event log has a unique GUID, right? And that's where there could be differences.
Well, the error, let's be really careful about what I mean follow the CPER format. It will be a CPER formatted record, but it can be an OEM record, not a memory record. It just has to have the CPER wrapper and the GUID, and then the vendor's decoding tool will be able to decode that into a format that we can make sense of.
Okay, let me rephrase what you're saying. You're still saying that we will follow UFI spec from a header point of view, but the content could be vendor specific. Did I get right?
The format of the memory error record descriptor, everything behind the vendor's memory error descriptor can be peculiar to that vendor, so long as we can decode it and consistently to get this to memory vendors.
Okay. Did you hear what I said?
I did, but I didn't understand. I think there's some confusion about what we mean about. I want to be super clear on what we mean about the CPER error records.
Okay, so where is the difference now? I am not following. Well, I think
Well-
what you're saying is what I was saying, but it seems like there's a disconnect.
Well, I'm saying that I don't care about this, the CPER UEFI defined memory record that exists in the UEFI spec. It can be, so like at HP, we ignored those. They were not very useful. We built our own error records, but they had similar data, but we had a big superset, and it was organized according to how we designed our chips. And so that's what I'm saying here is, we're following the CPER format. We're not following necessarily the memory error record descriptor defined in the CPER spec. If we have a vendor specific GUID for the memory error record from that vendor, that's completely fine. They just have to decode the data out of it consistently so that we can interpret it.
I see. And you don't want to push back, take this schema and then take it back to UEFI to.
No, I strongly don't. And the reason is that like I said, some folks have you ever looked at the syndrome-based decoding where you have to do some math? And some folks log bit flips. I mean, things are logged differently in chips, and so the process of decoding may do some transforming of the data to fit the format we've described here. And so where the vendor does that work, whether it's in the chip itself or whether it's in the decoder, is irrelevant to us. We just want to get the data that we need to analyze memory errors.
Yeah, I'm not fully aligned on that, but that's okay. Let's continue.
Okay, well, why don't we discuss that a little later?
Yeah.
Okay, so then I guess the next section is I think Jungmin did this. Let's see. I'm not sure what to say here. Does anyone know these registers well enough to say whether we've defined it correctly or not?
It's a little unclear to me from Jungwin's comment if we're concluding that's good or not.
Let's see. 5 and 6 still.
What is the question here? I'm not sure.
I guess the question is, at boot time, do these logs still contain data? And that was a question folks had, and so I think we still need someone to look at that. Jungmin, are you here? Let's see, I'm looking at who's here. So I don't think we have anyone from Samsung, do we? Let's see. I'm having trouble seeing all the names. I'm having to look at my computer. So I guess, we don't want to log this if it's not there.
There's a further comment from J.M. Lee.
That's him. That's Jungmin.
Yeah.
Okay, so he's saying he's going to check whether there's a way to not disable the register clearing logic. It looks like by default it will clear, right, at the power on, but there may be some way to not clear it. He's going to check. But do we need this information on every boot? I mean, sorry, do we need this information to stick around, to be sticky after every boot?
Well, if it's sticky, we want it. That's what we're saying. But we
But
don't
if you already
It-
collected the data, then why do we need to keep there? You should clear it, right, the boot? I don't know. I'm just
Yeah, and sticky through what instance here, Drew? Are we talking about like initial boot? Or if you have like a system reboot? Either?
I think it's either.
looks like this is global history of error logs, a global error count. What a global error count means here, I mean, from the last system boot, last system power on. After that, every boot it keeps accumulating it.
This is you just need to read the PMIC spec. It's a register in the PMIC spec.
Yeah.
It's register 4. So okay, well, can we give someone else an action item to help look into this?
Yeah, Drew, I'm sending it over to our module development team right now. You can tag me on that one too. So we can
Okay,
figure
let
that
me
out.
see. I didn't-
Just looking
This
at it, I can't think of a way how these would be persistent through like multiple boots, but I would think you should have the most recent boot information.
Yeah, that's makes sense to me. So if you could look into
And this
that.
should be consistent across, this is JEDEC spec defined, right? Should not be just Samsung specific. It should be followed by all the.
That's the
VRAM.
point.
Yeah,
That's
it'll
the
be in the
point,
JEDEC
Anil.
PMIC spec.
It's the PMIC spec.
Right.
So yeah, it's a PMIC question. Jong Min just raised the issue and was going to look into it. That's all. Okay, all of these things are reviewed. We stopped here. Okay, need to define what perspective these addresses are captured. Let's see. Okay. So yeah, there's a logical and physical address that's used by JEDEC to reference physical address as the XY coordinates of the cell in the chip. But if you look at like Patterson and Hennessy and the Microsoft operating system docs and the Linux spec and like almost everyone else, physical address means OS physical address. So I think we can distinguish a DRAM physical address by just saying OS physical address.
Yep, that seems fair, Drew.
Um,
Dale's point here is that people often just say physical address and we don't know which one we're talking about.
Got it. Okay.
But OS physical address, that's fine.
And we won't even know when we log it what the DRAM physical address is because that's proprietary to you. So you've got to
Right.
tell us.
Yeah.
We already talked about it last time, right?
So that was a different meeting. And then the device, bank group, bank row, and column. I understand there may be confusion here. I guess what I would say, memory error location, maybe we say as logged by the memory controller. It's this is really, I know you all may have a different knowledge of column once you look inside the chip. I'm just saying column address. Or would that help? Would it help to say row address, bank address, column address?
In this case, Drew, I guess we'd be talking column address as seen by the system, right? So you'd have column address for an entire prefetch.
Well, it's whatever we put on. I mean, so the memory errors occur when we access memory. So this is whatever we put on the bus to the DRAMs, right?
Okay, yeah.
So how do I say that, right?
That's a good question.
Yeah, this is the memory error location from the system point of view, right?
Yeah.
So what's a row and what's a column in the system speak is different than a row and column at the DRAM die level.
Yeah, it can be.
Yeah, it can be. And the main thing that's usually missing is, from the system level, we get a column, what we call a column start address, which gives you the address for the entire prefetch. But then within that, you won't necessarily be able to decode that down to single or individual memory cells without DQ information.
Yeah. Yeah.
Oh, yeah, that good point.
So that's the main difference usually, is we can get, we can get roughly where things are in the array, but not all the way there without DQ. I guess, do we have that called out? I guess, is that covered in
This
the
is
error
device,
bits
right?
location? Next one.
I think what you're referring isn't device ID would be kind of synonymous to DQ, because depending upon by
No, it's it's not. It is which device you're referencing. So when you have if you have a 10x4 DIMM, it's which of the 10 DRAMs.
Yeah, isn't that is what I'm just asking a question, anyone. When you say DQ, are you referring to like from the device point of view, or actually literally a DQ?
Literally a DQ, Anil, because if we don't know which of those are failing, like if we know which device is failing on the DIMM, which DRAM device is failing, but we don't know which DQs within that are failing.
Isn't the
can't
column
decode.
so device and column together, wouldn't that give you the DQ?
No. So Neil, there are 4 DQs from a by4 DIMM, and there are a lot. There are like what 16 beats from them. And so when you say, give me a row and a column address, you give that to the DRAM, and the DRAM takes a section of the column and shifts it out the DQ pins. And the mapping of those columns to the beat of the DQ pin and which DQ pin it is can vary. We don't know that all the time. And you can't really assume that. So that's where the memory vendor can.
No, I think there's a difference. I understand, Drew, what you're saying. I think if you look at from memory control point of view, this is a memory control point of view. This column address, column concept here is from a controller point of view.
That's right. This is the column address.
Right. So when memory controller sends an address on a command address bus, there's a row address, there's a column address. Yes?
Yes.
And that goes to every DRAM device. Okay, right? And each DRAM device, let's say by4 DRAM device, is going to decode this for the decoding of that column address. Now we know there's a by4, let's say it's a by4 DIMM, that means 4 DQs. Are you with me so far?
Yeah.
So as long as I know that these are the 4 DQ this column map to, from control point of view, that's what control cares. After that is all DRAM, within DRAM. That column is different.
So to know so you know the column address, that's the column address, but then actually the column address gives you a range of columns, and that is looked up. You have to look at which bits were shifted out in the DQs to go any more precise than the column address.
Yeah, all I'm saying is from memory control point of view, right? If I know the device and the column address, then I have, at least my view is all clear. I don't need.
Well, you need all of these things. This is.
Yeah, no. Okay. Do we need a DQ and additional DQ field here?
Well, I think from your perspective, no, Anil. And I think what I'm asking for is covered in this error bit locations row on the next one.
This is where you get the DQ.
Exactly. Yeah. So I think we're all good as long as we're clear that memory error location one is from the memory controller perspective, and then the error bit location is the additional information that the DRAM vendors need to be able to fully decode within each DRAM device.
Correct. Yes.
Yeah. So
all I was pointing out that we don't need a separate DQ field. That's all.
Yeah, I think you're right. I think what we have here is perfect.
This infers the DQ field. Yeah.
But we need to know where the error is within the burst, right? So the column, from a memory controller point of view, isn't it the first column, and then the DRAM bursts out, another bits from another 15 columns, right?
Correct.
So don't we need to know also, burst location?
Yeah, the syndrome will tell you, right?
Yeah.
Yeah.
Because syndrome is
what's covered there.
Yeah. Let's say syndrome has, let's say 32 bits, right? I mean, sorry, it's a 64 bits. So if the bit zeros is flipped and corrected, that's your bus 0, right? If the bit is
Yeah, I'm just going to say we clarified this. I think we're good. Okay. So I think do we have OS physical? I think this is the first time we've referenced the OS physical address. Yeah. So I'm going to mark this as resolved since we clarified it. Okay. There's no standard way to report ECS data except dumping the registers, and that's what this is. And that's, I don't understand. I'm not sure what you're asking for. I think the easiest thing to do, since the registers are JEDEC defined, is just to dump them.
Yeah, I think what I was going with this thought process here was if you just dump the registers, somebody has to do one more level of decoding. And I think maybe, Drew, you already responded that the way I was thinking that when the log comes out, right, it should be as descriptive for a layman to figure out what is the fault. And when I say layman means, whatever tooling.
Well, that's the
tooling
decoded log. The decoded log.
No, and that's what now. So you kind of clarify that what I'm trying to achieve is not going to achieve here. We still have to rely on a vendor-specific decoder and analyzer to get that output, which is meaningful for hyperscaler.
I mean, they may even decide to compress their CPERS for a bandwidth problem in their chip, and that's fine. When they decode it, they can decompress it. So that's kind of the point, is that we're saying what we want in the end and not how we get what we want in the end.
Yeah, I mean, okay. I'll just say one more thing and then I'll stop. I mean, JEDEC spec already defined it. It's out there. Whosoever has access to JEDEC spec, they can look at the register, right?
Yeah, I think we just say this is
so
the
they are
JEDEC.
standardized. So there's a standard only, right? There's no vendor specific thing here. So why don't we define how to decode that and just call that out rather than?
Why can't we just? Why do we even need to decode it? Because this is really puzzling to me, Anil. It's JEDEC defined. We don't need to decode it. Everyone knows what these registers mean. So we just captured the registers, and the memory vendors know how to use it. Why do we need to do more?
Yeah, I was looking from a hyperscaler infrastructure consumption point of view. If I get this raw data, right? If I get this raw data.
Well, we have access to the JEDEC spec as well. What's the big deal?
Yeah, that means somebody has to write a code to decode it.
We'll call the vendor decoder and call the vendor analyzer and start with that. I mean, even if you're doing AI memory stuff where you're trying to do something really clever, you can always feed the output of the analyzer in as an expert system and include the decoded.
Okay. I think you can just clear it, resolve. Because I think there's a difference in opinion here, Drew. I'm not going to fight this right now. Because my thought process is that I want to see as much of decoding, simplification of our tooling. Okay, but here what you're saying is that, well, we always have to rely on the vendor specific code, and that I want to minimize the dependency. Okay, even for simple thing like decoding register, if you rely on vendor code, that's like putting a lot of pressure on vendors and getting it right in our implementing and integrating into our tooling.
Well, I mean, heaven help us if we can't decode the ECS data. Gosh.
Oh yes, there's too much of. We already saw the problem, right? Two vendors decoded information is different, and now we are scratching our head. Okay, what do you do now? Well, we have to now implement tooling. Okay, if it is this vendor, then do this. I mean,
well, let's get it fixed. I mean, this will push that to be fixed.
It won't. It'll be, in fact, make it even worse. We're going to say, well, we're going to do decoding the way we want.
Well, for this specific instance, from the DRAM perspective, like, Drew, I think what you said makes sense. Like, these are JEDEC defined registers. The formatting is defined. If we can just directly get those mode register values, those should be in the same format for every DRAM vendor at least.
Yeah.
So I don't know from kind of the chipset vendor perspective, but from the DRAM perspective, these should be
Oh,
fine.
absolutely. I think the question is can we decode them consistently? And
I mean, yeah, dumping register is okay. I'm not saying not to dump, right? But then there's additional parsing of the data, which we have two choices, right? Either we always rely on vendor-specific decoder that we need to integrate in our, and this vendor means like system vendor, not DRAM vendor.
Yeah.
Right? And variations from one system vendor to other system vendor.
so Neil, here's the beauty of this approach. I don't think you're getting it. We're going to feed the output of the system vendors thing to the memory vendors, and they're going to need to get it consistent so that the memory vendors tooling works consistently. We will actually have a software process in place where we are releasing and testing code that will force this to work more consistently.
Yeah, I think you're right. I'm not getting it. I'm still not getting my head around this concept. So that's why I'm saying I'm going to shut down now.
Okay, well, why don't we can talk later today. We got a one-on-one, although I need to move that. Someone's scheduled over it. But let's talk through that later today, and I'll see if we can figure it out.
Sure. Thank you.
Okay. PMIC is trending to have additional error registers. Consider updating when the spec is officially published. Sounds great. Right? No argument here. So I'm going to mark this as resolved unless someone knows that the PMIC has had additional registers added.
Yeah, I'm not sure what the status is, Drew. Do we have a general philosophy on updates here as specs evolve? From the DRAM perspective, like we locked this into DDR5, but the RCD and PMIC generations are moving faster within DDR5 than like the DDR revisions are.
I mean, I think we just want to grab anything we can. So if there's something there that helps us figure things out. And I think as far as like the question will be, can the CPU vendors gather additional PMIC registers? But I think if they can gather, these, they could gather, if we decide that we want to grab 0xe, seems like that would be just something we have to add to the spec.
Yeah, we'll end up kind of tiny bits out of date as these new specs kind of publish and
we can
become
just say
standard,
which
but
spec version we are based
Yeah.
on.
Yeah.
And then and we can just say this may change based on future PMIC spec versions.
And I think the other thing you can do is you can always add a register to a CPER, right? You can add a register at the end, and so then it just becomes reserved if you don't have that in that particular version and you're using the new CPER, you just don't fill it out. You don't mark it valid. So there are ways to tackle that. So do we have a PMIC spec version that we could reference? Like that might be worth doing in the.
Yeah, I don't see one in the references section, so I guess we should add one.
Okay.
I don't know where that would be though.
Is there so Kevin, is there like is there a PMIC spec version we can reference, or do they tend to be like specific to the vendor of the PMIC? How JEDEC defined is it?
I don't think we have Kevin today, Drew.
Roy, do you know?
Yeah, currently at JEDEC, I just visited the JEDEC site. The PMIC 5010 is now standardization. So I don't know. I have no idea for the 5030. Probably it's a different discussion table. So I don't understand.
So we'll update when new PMIC specs are released.
Oh yeah, the latest version is the 5010.
Is it the
Okay.
one that I put in the chat? Is that the one?
I can't see the chat.
Yeah, that looks right, Mita.
Okay,
Mhm.
then we can
Could
just add
someone-
that to the reference.
Yeah, Mita, do you mind putting that
Yeah.
into the document?
Yep, I'll do that.
Thank you.
Yeah, thanks for grabbing that so fast.
Okay.
Yeah, I'm the same, Roy. I have not been in the JEDEC discussion, so what Kevin's referencing there, I've just heard of it, but I think just calling it at 5010, the current standard, and saying it'll need updates later is good.
Okay, and you know, I'm just going to reply. Well, update when new specs are out. Okay. Let's see. So Evan, you worked on this, or did we assign it to Shen? Should I just clear this?
Sorry, Drew, stood up there for a second. Yeah, I think just clear that.
Yeah.
Those are very old ones from just kind of getting an initial pass together.
Yeah. System fault analyzer, SFA. Yeah, I think that's right. I'm going to go,
Yeah, right.
sorry, I'm going to scroll to figure 1. Figure 1. Vendor specific fault analyzer is what we're calling it now. Oh, system fault analyzer, I see. Yeah, that's true. That's exactly right. Okay, good comment, Mita. Let's see. Okay, Roy will take a first pass. That was in September.
Oh, I added those one in the log detail in the table.
Okay. In the table above or the table below?
Table below.
Okay, so I'm gonna I'll just say this is in the table below and close it.
Yes, the table below the public information means that the information which is shareable, and those one identified in the table log below log details.
Is that the visibility access? Let's see. I'm going to try to
Yes,
close.
for example, the row fault, multi-row fault, column fault, and bank fault, etc. That was my suggestion.
I'm sorry. I'm trying to. Oh, right here. Okay.
Yeah, right.
I'm sorry. I was trying to figure out what you were talking about. Okay.
Mhm. Oh, it's not updated. I will update it just after this meeting.
Okay. Okay. Sounds good. And then the contents, these 4 columns seem identical between the 2 rows. Oh, there's the table always says the same thing. So, Roy, when you do that, can you consider what Mita also mentioned here? And maybe we just put text, and that way we don't need the columns and it doesn't have to be so wide.
I think we
Okay.
removed such columns from other tables, but yeah, this one still has it. So
Yeah. Well, Roy, we'll give you I'll just, I'll say Roy will clean up this table. Is that
Okay.
okay? Or Roy will
Okay.
update the table?
Yep.
If that's okay.
Yep. Okay.
Huh. Well, I don't appear to have lost all the email addresses.
Okay.
And so
I said Roy.Chang.
yeah. Oh, is that your email address? Oh, I can do that. I don't know if that'll work. I'll try it. At SKH
us.sk high sk
at
US
US.
dot sk hynix
Thank you.
.com. Yep.
Oh, perfect. That worked. Okay. Thank you, Roy.
Mhm.
Okay. Will there be a host? Oh, oops. Okay. I hit the wrong button. Okay. Will there be a host?
Yeah, so Drew, I was just thinking loudly here in my mind, when the analysis results, right? We have dim serial number and then all the details here. Typically we associate with the host ID.
You mean like which machine?
Yeah,
Yeah. So, um,
I mean, taking a dim serial number and trying to figure out where exactly it is, in which machine, which data center is it's going to be a nightmare. Typically,
well,
we have
there's an assumption throughout the entire framework, though, that you gather a CPER and you know where the CPER came from, and so that when you generate, let's say, a CPAD, you know to send it back to the machine from which the CPAD came from. So, I think the assumption is that you know where you got the log that you fed the analyzer. Is that not true?
I don't know. If some way we can join them, then easily joinable, then okay. But I don't know how.
Well, okay, just imagine you have a collector out there and it's collecting error logs and you're going to analyze that error log and you get the output of it in this. The collector needs to know where it got the error log,
Mm-hmm.
right? The error logs don't have the machine, CPERs, as defined, tend not to have the machine name in them. And what you have to do is you have to go, I got this CPER from this machine. And then when you analyze it, you go, okay, the CPER is from this machine. The analysis result is for this machine.
I see. So you're saying looking at the CPER main header, we should be able to join them together.
If your machine,
we can add it. Yeah.
if your machine logs it in the header, but a lot of machines don't. The collector just remembers where it got it from.
Uh-huh.
So most collectors in hyperscalers, they go and say, I'm grabbing an error log from machine X. And then they put it in a database, and the database has a row. It says, at time X, I talked to machine X and I got error log. And then you feed that to an analyzer, and you would, when you're giving the error logs to the analyzer, let's say we're doing the time series analysis we've been talked about. You get the new CPER, you decode the header. The header then says, I go to this analyzer, and you say, oh yeah, I know this analyzer wants 90 days of logs. So you go query the last 90 days of logs from that machine. And then you feed that to the analyzer. And so the infrastructure has to keep track of which machine logs came from. That's just kind of it's a really basic thing. And then when you output the information about the failure, you should be able to know that I fed the analyzer an error log from this machine, and therefore the output of the analyzer applies to that machine also.
Okay. I mean, for me, whenever I look at any error log, there's always a host ID associated with that. In every
Yeah,
record.
and it's because the collector associated it.
So you're saying we don't need it here, it's captured somewhere else.
Yeah, I mean, I'm 100% aligned with you. It always it's pointless to gather an error log if you don't know where it came from. So you always have to assign it to a machine. But the point is that the error log, like usually the thing down in the chip doesn't always know what this chip name is, because that's an OS concept. So like, let's say we're doing traditional in-band error logging. The SMM code that would build a CPER, let's say in the old way of doing things, has no clue what the OS calls itself. Absolutely not. And so it says, here's an error log. And the collector in the OS goes, okay, here's your error log, and I'm going to send it out. And the machine, by sending it out and saying, this is from me, tells the collector who the machine is. And so the collector has to track where it got the error logs. But
All right.
that's just kind of done everywhere. I've never seen an infrastructure that didn't, track the origin of the error log.
Mhm.
So
Yeah, I see your point. So what you're saying is this is a much lower level result here. Somebody has to wrap it around with that
Yeah.
information, which is not relevant here. That's okay. Then you can ignore my question comment.
Okay, so I'm just going to say I'll put an explanation of the machine name ID should be known by the collector. Yeah, I think that's the answer. It's a good question, but I think that's the way it's got to generally work. Okay, so I think we're almost out of time. From the CPU analyzer.
I think we discussed this one previously, Drew.
Yeah, I did too.
I think at least the alignment between, well, Jongmin's comment there and then mine also is that we don't want to get into that level, certainly not for this. I don't really see a point in talking about things in here that would require an NDA to implement anyway.
Yeah,
Right?
yeah, I agree.
I don't want to violate the O here in OCP.
Exactly. So I guess how can I tell me what to say here? I agree with you strongly, but I'm not sure how to put it.
I think what's included in the tables, Hynix, Micron, and Samsung have kind of aligned on this is what we want to share at the OCP level. And
Right.
everything else we can kind of handle outside of it. But we can probably close out this comment.
Mhm.
Like nothing in here is to keep a memory vendor from working directly with an Intel or an AMD or whoever, but we don't really need to have that discussion in here.
Yeah, shared between the companies under NDA or something, right? I respect that, and
Yeah.
that makes perfect sense. Okay, so I'm going to mark that. Okay, that sounds good.
This one still needs clean up here, Drew. This
Oh,
is
yeah,
part of the
I will clean up.
Okay, sounds good. And this will be part of your cleanup too,
Yeah,
please.
I will add this description to the table.
Okay.
and I think we're okay there too, Drew.
Okay.
That was a discussion around the OS physical address again.
Okay.
Since we have that cleaned up and linked earlier in the document.
Yeah. Yeah.
So,
Okay. I think we're
right.
out of time.
oh, let me check my understanding is correct. So all the physical address described here means OS physical address, right?
Yeah. And well, when we say that, if we see the word OS physical address, then
Or
it's an
DRAM
OS.
physical address, right?
So I think if we want to talk about the XY coordinate inside the DRAM, that would be the DRAM physical address. But that's
Mhm.
usually proprietary anyway. So, I mean, if you told us too much detail there, we could reverse engineer your part. So,
Yeah.
Yeah, I
right?
think the other piece, Drew, is that sometimes the OS physical address, the OS physical address, and then the sometimes the physical address on the system is called like what the DRAM bus is actually seeing
Okay.
on the
Well, I
memory
think we
controller.
call it like channel address or
Sometimes that can be
something.
different, but
Yeah. Well, and DRAM row address to OS physical address.
Yeah.
That seems clear.
Mhm.
everyone likes to call the addresses that they look at the physical address.
Yeah. So I'll just try to get in the habit of prefixing it
Yeah.
with OS.
Yep, I think that helps a lot.
An OS physical address should not be ambiguous. It is the operating
Yep.
system's view as opposed to, it's not a virtual address, it's a physical address. Yeah.
I
If we
think
do
last
that-
time, didn't someone took an action item to write down or maybe draw a picture of clarifying what we mean by OS physical address?
I think we just need to
Or-
put it in the,
Yeah, it's a good idea.
we'll put it in the,
Yeah, it'll be good to just draw it out, do because address translation is a nasty thing. If you don't draw it out, it's very hard to understand, and it's not that difficult. If you want, I can take a stab at it, and then someone from DRAM vendors can add the translation from memory control view to the DRAM view.
I tell you what, I started a glossary entry and I'll give it to you. Sound good?
Mm-hmm. Yeah, so there's OS physical address. Well, it starts with OS virtual address, OS physical address, then memory controller address. Okay, and then after that, then DRAM address, right? So there's like 4-level translation.
Okay, this and
I'm pretty sure there will be one more level, that translation within DRAM.
well, that's the physical address. So, but we're never getting that. I mean, not without an NDA. So, the XY coordinate of the bad cell. I mean, like that DQ. There's some mapping in there that's usually proprietary, and so we don't get that unless we have an NDA and a trusted relationship. So,
Yeah,
but anyway,
I'm
yeah,
talking
that
about
sounds good.
Yeah, I'm talking about clarifying when we say address, what does it mean?
Yeah.
From which point of view, right?
Yep. And so I just gave you an action item here. Do you mind taking it from there? Okay, I'm going to mark where we stopped. And so we have a few more times, and I think we made progress. We're getting there. So
I just added this question.
It'd help if we didn't go backwards, but okay.
No, I just caught my eye. This is a question we don't have to discuss here. Let's defer it for. Let's chew on it. Maybe somebody can respond. I don't know what that means. End user means here.
We can clarify that. Okay. Stopped here on 2/11. 2025. Okay, so we'll pick up from there then. We'll just go back a little bit, and because then Roy will have updated the table, so that's not that big a deal.
Okay. We'll do that.
So is that okay? Can you have that for next week?
Yep.
Or next meeting?
Next
meeting. Next meeting. Sorry.
Next meeting. Okay.
Sounds good. Okay, thank you so much, everyone. We're getting there. It's the painful end, but I think we're getting close to 1.0.
Yeah. Thank
Good
you,
stuff.
everybody. Bye.
Okay. Hey, Anil, do you have a sec? Oh, I guess then you left. Okay. Talk to y'all later.
Yep, bye.
Bye.